Okay, today we're going to go over some practice with the scatter plots. Questions 1 through 6, we are going to focus on identifying if they have a positive, negative, or no correlation. And then we're just going to practice estimating R. Later, we're going to find out how to calculate R. So what's important here is not that we get R exactly correct, but that we can kind of rank 1 through 6, which one is strongest, which one is weakest. Okay, remember positive and negative correlations. On the graph, they look like a positive slope or a negative slope. And then when we connect it to context, a positive correlation means that as one variable increases, the other one increases as well. And a negative correlation means that as one variable increases, something else decreases. So for example, for Barbie, as the number of rubber bands increased, her distance increased. For a negative correlation, you might say how over time, so as time increases, the number of COVID cases decreases, or something like that. So we're going to go ahead and get started here. Question 1. This one is a little bit tricky to decide positive versus negative. But for me, looking here, because this one all the way to the far left is starting low and I can see it going to one that ends high, I'm going to say that this has a positive correlation. And with this positive correlation, it's very weak. It's not very strong because you notice how we really couldn't even tell positive or negative. We kind of had to think about it for a second. So I would say this is pretty weak. It's got some up here, some down here, not all tight to the line. Maybe we might estimate this is 0.1 for our R. Question 2. This one definitely looks like it has a negative correlation. And R, it looks like they're pretty close to that line. So I'm going to estimate R to be now remember we said negative, so it has to be a negative R, negative 0.8. Question 3, this one looks to be following a positive line. So this is a positive correlation. And while my points do all seem to follow that upward trend, it's not as tight to the line as question 2 was. So this one's R should be a little bit smaller, or let's think the absolute value of R should be a little bit smaller than that 0.8. Maybe for this one, I'm going to say it is about 0.62. All right, question 4, again, this one is positive. And these ones are really tight on that line. So this is going to be a R very close to 1. I'm going to say maybe 0.96. Question 5, this is a negative correlation. And again, it looks pretty tight to the line. So I'm going to say R is about negative. Let's go with just 0.9. And remember, it should be a negative 0.9. There we go. Now, question 6. This is just a circle. So for this one, I would say they have no correlation. Right? I can't really draw a line this way or that way. It's all equal on the side because these are drawn in a circular shape. So no correlation. Maybe you would say R equals 0. But really, we don't even have to worry about R here. There's no correlation. So, but very weak would be 0. All right, let's go over question 7. A history teacher asked her students how many hours of sleep they had the night before a test. The data below shows the number of hours the students slept and their score on the exam. Plot the data on a scatter plot, then describe the relationship. All right, so I'm going to plot this. When this got copied, it didn't quite do all the numbers down here exactly as they were supposed to be. So I'm just going to update this right now. so that we can see it's nice and already labeled for us, which is good. If you notice the way that it's labeled, number of hours of sleep is going to be our explanatory, because that's always on the horizontal axis. And then test score is going to be our response variable. So we are saying that hours of sleep could explain or predict your test score. All right, so let's see. 8 hours and a score of 83. Be about here. 7 hours and a score of 86. 7 hours and a score of 74. 8 hours and a score of 88. 6 hours and a score of 76. 5 hours and a score of 63. 7 hours and a score of 90. 4 and a score of 60. 9 and a score of 89. And 7 and a score of 81. All right, so here is our scatter plot. Now we want to describe. Remember, when we describe, we use DUFs. So direction, unusual features, form, and strength. So as I go through this one, this definitely has what I would call positive direction. So it does follow that linear shape. So for form, it does follow a linear line. For strength, it's kind of tight. It's not the most, but I would say it's slightly pretty strong. And unusual, I wouldn't call any of these to be particularly unusual. It does look like we kind of have a gap in here, but that gap is not really big enough that I'm going to call it unusual. We have people at 4 hours, 5 hours, 6 hours. So that gap is not really a large enough gap in the explanatory that I'm going to consider it to be unusual. So let's write this. The relationship between hours of sleep and score on test has a fairly strong positive linear relationship. There are no unusual features. So here I've described direction as positive, I've said strength as fairly strong, and I have said form as a linear relationship. So I've described everything. Now, one thing we might talk about here is just the difference between correlation and causation. Remember, correlation means that these two have a relationship. So there's definitely a relationship between the number of hours slept and your test score. But does that mean that sleeping more will cause you to have a higher test score? That's not necessarily the case, right? Remember, just because you're sleeping, it doesn't cause your test score to go up. There's no causation here. And the reason is there's a lot of other factors to consider. Maybe people who are sleeping more have studied all week and therefore aren't cramming for their test all night. That could just be one example of how there are other factors leading to this relationship. So remember, correlation does not equal causation. There's a relationship, but it doesn't mean that one causes the other. All right, let's go for another example here. Question 8. Assume that during a 3-hour period spent outside, a person recorded the temperature and their water consumption. The experiment was conducted on 7 randomly selected days during the summer. The data is shown in the table below. Create a scatter plot with the data. What is the correlation of the scatter plot? So we're going to estimate R. Hint, do not use the day on the scatter plot. So we are creating a scatter plot where water consumption is the explanatory and where temperature is our response variable. Again, this just got all messed up here. So 16, 20, 24, 28. All right, now I'm ready. So let's go ahead and plot this. The first one, water consumption is 48 and temperature is 99. So 48 up to 99. Water consumption is 27, temperature is 85. So 27 and 85. 97 or 48 is the water consumption. So you have to be careful here, right? Because we're doing water consumption first, then temperature. So 48 and then 97. 48 up to 97. Ooh, 2 plots right here. The next one, 16 and 75. The next one is 32 and 92. Then we've got 25 and 85. And last 20 and 83. All right, so looking at these, this definitely has a positive correlation. They seem to be fairly strong again. So for R, I'm going to estimate R to be definitely positive. Maybe let's say about 0.89. I don't know. That seems about right. And then let's describe the relationship. Remember, we are following Duff's direction, unusual features, form, strength. Direction is positive. There do not really seem to be unusual features. The form is linear. The strength is fairly strong. So there is a positive relationship between water consumption and temperature. The scatter plot or actually I'm going to say the data forms a fairly tight line. There are no unusual features. So notice I wrote it a little bit different than the first one, just to show you some variation with Duff's. But I mentioned that it is a positive relationship. So that's the direction. That's because it's pointing up. I mentioned that it is creating a line, so a linear form. I mentioned that it creates a fairly tight line, so that's the strength. And then I just mentioned there are no unusual features. All right, for 9 through 15, now we're thinking about the correlation in terms of context of a problem. So do we think it has a positive, negative, or no correlation? So remember, for positive, I'll do positive in green. For positive, that means both variables are going up at the same time. Negative means they're both, or as one goes up, the other goes down. No correlation means that they don't have a relationship, that they could both do different things at different times. So, number 8, the number of hours a person has driven and the number of miles driven. So as you drive for more hours, so as my number of hours goes up, the number of miles I've driven also must be going up, right? If I drive more, then I'm driving longer and further. So this is a positive correlation. Probably a pretty strong one. Number 9, the number of siblings a student has and the grade they have in math class. Well, you could all have different numbers of siblings. You could have 1 sibling, 2 siblings, 5 siblings, no siblings, and then you could all have different grades. It really depends on how you apply yourself in class, how you enjoy mathematics, all these different things. So it doesn't really seem like having more siblings would give you a higher or lower grade in the class. For this one, I'm going to say there's no correlation. And if you think about this, if you have a hard time with that, think about reasons why one might give you a higher or lower. And if you can think of reasons where 0 siblings would give you a higher grade and a lower grade, that might help you to see why there's no correlation. So what I'm trying to say, for example, if I have no siblings, then that means that there's a lot more focus on me and my household. So maybe my parents can spend more money to get me a tutor, they can help me do well, they can focus on me. That could be a thing that leads to me having higher grades. But if I have siblings, on the other hand, maybe one of my siblings is really good at math and can tutor me in math, or they've already taken the math class I'm in, and so they could help me out, and therefore they could help to increase my grade. So I could see where having more siblings or less could both have an impact on grade. All right, the age of a car and the value of your car. So as your car gets older, its value typically decreases. So the more you drive your car, the older it gets, and the value of it goes down. This is what we would consider a negative relationship, because one goes up, the other goes down. All right, number 11, the number of weeks a CD has been out and the total sales. So as the CD is released and the number of weeks passes by, so as time goes on, I would think the total number of sales for that CD would go down. Probably as soon as it's released, a lot of people buy it. And then as time goes on, people probably already have it, so not very many people are buying it, so the sales would decrease. Again, this is a negative relationship because as one goes up, the other goes down. Number 12, the number of years a person went to school and their income. Well, the more you go to school, if you go to high school, you graduate high school, then you graduate college, then you get a master's, then you get a doctorate. All of those new degrees are going to get you into higher paying jobs. So your income is probably going to increase. So this is a potentially positive correlation. Now, could you find outliers to this case? Of course. Some people might go and get their PhD, their doctorate, and then decide that they want to, work at Target because they love Target so much. There are definitely outliers, but for the most part, this is a positive correlation. Number 13, the number of songs downloaded on your iPod and the amount of memory available. Ooh, this is a good one. So as I download songs on my iPod, the number of songs goes up, but then the memory goes down because as I keep downloading some, I have less and less space. So this would be a negative relationship, and I would say this is probably a pretty strong one too because they are directly affecting the other. A new song takes up space, so my memory automatically goes down. Number 14, the amount of time spent on the computer instant messaging your friends and the number of computers in your home. So if you spend more time instant messaging your friends, does that mean that you will have more computers in your house? I would say for this one, no correlation. And you could probably argue that if somebody in your house spends a lot of time instant messaging, that you'd probably want more computers. But I don't think it necessarily would work that way. Not everybody can just buy a computer because one kid likes to talk to their friends. So I would say that if one kid is hogging the computer, it won't necessarily lead to multiple computers in the household. So I would say no correlation here. 15, the age of a house and the number of people living in the house. So as a house gets older, does that mean that more people live there? No, not necessarily. I would say again, no correlation. Because if you move out on your own and you buy yourself a house, you might buy a really old house. So that would be a really old house with only one person living in it. Big families often, because they have so many people, they might choose to buy a newer house, a new model that has lots of bedrooms. So now a big family is living in a really small house. But there are cases where it could go the other way. So there's really no real relationship between those two.